Hi everyone. So in this video, we're going to work through another pure maths question from the AS 2018 paper. And this question is about exponential modeling with some logs. So the value of a rare painting, V pounds, is modeled by the equation V equals P times Q to the power of T, where P and Q are constants and T is the number of years. It's important just to underline the units so you don't forget the units in the question. T is in years since the value of the painting was first recorded on the 1st of January 1980. So let's just bear that in mind. I'll also actually interject here and just say that this formula, this is an exponential model. Why is this an exponential model? Well, that is because t, the independent variable, is in the power. So that is what you would call an exponential model. Great. So now the line L shown in figure 3 illustrates the linear relationship between time and log base 10 of the value since the 1st of January 1980. The equation of the line L is log base 10v is equal to 0.05t plus 4.8. Okay, so hopefully you can see that this is like a y equals mx plus c line. So the gradient must be 0.05 clearly, and the y-intercept is 4.8. So if you want to, you could label that there as 4.8. Great. So the question, part A, says find two 4-sig figs. Let's just underline that. The value of P and the value of Q. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level Maths topics that will come up in your 2027 exams. So now that the 2026 exams are finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018 and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up to the app, and you'll be able to access all of these 2027 predictions. Now, what I will do for this part A, I'm just going to write down the equation of the line again. So it's log base 10 v is equal to 0.05t plus 4.8. Now, what I want to do, I want to use that equation of the line there and convert it into this exponential equation up there. So we've got to use laws of logs, laws of indices maybe, to try and convert this log base 10 equation into a v equals something. So obviously I want to get rid of this log base 10 there. So we just have a v isolated on the left side because that's what we're looking for. How are we going to do that? Well, let's think about the inverse of log base 10. What is the inverse of log base 10? Well, the inverse of log base 10, so log base 10 of x, the inverse of that, the inverse function, is 10 to the power of x. So if we raise both sides of this equation with a base of 10, like so, that will cancel out the log base 10. Okay, so 10 to the power of the right side as well is equal to 10 to the power of the left side. Great, so now the log base 10 disappears. Now this just cancels out. So we're left with v is equal to 10 to the power of 0.05t plus, sorry, my plus sign is too low down. Let's move that up in the power where it should be, plus 4.8. There we go. Now let's think about laws of indices. So again, we're trying to get the right side into the form pq to the power of t. So we're not quite there yet. Think about rules of indices. Okay, so when you add the powers, that means you multiply indices. So this is 10 to the power of 0.05t times 10 to the power of 4.8. Now, it may just be easier to write the 10 to the power of 4.8 first, and then the 10 to the power of 0.05t. Now then, we're almost there, okay? So again, we're trying to get p times q to the power of t. We're almost there, but let's just think about one more rule of indices. So remember, if you've got x to the power of n times t, this is the same as, I don't know why I put brackets around there, but oh well. This is the same as x to the power of n to the power of t. So you can just rewrite this right-hand side of the equation as 10 to the power of 4.8 times by 10 to the power of 0.05 to the power of t. And now we've done it, okay? So clearly the 10 to the power of 4.8 is p, and then the q is this 10 to the power of 0.05, and then to the power of t there. So again, the question was, if we just scroll up, find the value to 4 sig figs of P and Q. Okay, right. So what we want to do is just literally work out P and Q now. So P is equal to 10 to the power of 4.8. Let's go to the calculator. 10 to the power of 4.8 is equal to 63,000. I'm going to just write this down here. 63,095.73, so on and so on. We want 4 sig figs. So to 4 sig figs, I need to, well, the 9 needs to round up to 10. So this would just be 63,100 to 4 sig figs. So that's P. And then lastly, Q. So Q is 10 to the power of 0.05. On my calculator, this gives me 1.122. And that is to 4 sig figs. 1.122. 4 sig figs. Perfect. So that is part 8 done. Just another quick interjection. If you are currently doing Edexcel A-level Maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. Now let's go to part B. So part B says, with reference to the model, part I, interpret the value of the constant P. So the constant P, what I'll just do here, I'll just write down our formula. So V is equal to P Q to the power of T. And again, this was, in this case, 63,100 times 1.122 to the power of T. Sorry, this X is really annoying me there, that time sign. There we go. Okay, so the value of P, this 63,100. Now, when you have a model like this, an exponential model, that constant at the front is going to be your initial value. Okay, so let's just think about it like this. If you sub in t equals 0, well, the value will be P times Q to the power of 0, clearly from the model. Okay, Q to the power of 0 is 1 because any number to the power of 0 is 1. Well, apart from 0, that's undefined. 0 to the power of 0 is undefined, but obviously Q is not 0. So this is just going to be P times 1, which is P. So P is your initial value. But to make sure you get the mark, you don't just want to say that, oh, P represents the initial value. The initial value of what? So in context of the question. So what you want to say is P represents the, sorry, my handwriting's got really bad there. The pen's messed up a little bit. Let's just write that again. P represents the initial value of the painting. So of the painting, and on what date? Well, it was the 1st of January 1980. So relate it back to the question. Great, so that was part I, and then part II was to interpret the value of the constant Q this time. So this 1 point, yeah, this 1.122 value. Okay, let's do that here. So with this setup, and again, I'll just write down the equation again. V is equal to 63,100 times 1.122 to the power of t. So what is this there? Now, if you remember back from GCSE compound interest, this formula looks very similar to a compound interest style of formula, okay? So that 1.122 represents a 12.2% increase per year. Okay, that's what that represents. Because remember, t is in years, right? The units of time in this question are years. So that would represent a 12.2% increase per year. So for the mark, I mean, what you could just say, that Q represents an increase of 12.2%. Instead of saying of, I'll say in the value, sorry, in value of painting. And it's very important to state the units per year. Again, the units here are years. So that's one answer you could say. I'm also going to write down an alternative answer. You could also just say that Q represents the factor of change in the value of the painting, and again, state the units per year. You could also say that as well, and that would also be an acceptable answer. Now, one thing that I see a lot of students do with a question like this is they'll say that Q represents the rate of change. You don't really want to say that because the rate of change is dv by dt. So differentiation gets you the rate of change. The 12.2% or the 1.122 is not the rate of change. So I would not say that. Now, I have seen a couple of mark schemes that do allow you to say that the the Q value in this case represents the rate of change per year. But I would avoid saying that, to be honest, because mathematically speaking, it's not. It is the factor or the proportional change per year. You can say that as well. That's fine. Now then, let's go to part C, the last part of this question. Find the value of the painting as predicted by the model on the 1st of January 2010, giving your answer to the nearest £100,000. Okay, so 1st of January 2010. So we started again on 1st January 1980. So 2010 is 30 years later. So we're going to just sub in t equals 30, right? So part C, sub t equals 30 into the model, which was V equals 63,100 times by 1.122 to the power of t. So the value is going to be 63,100 times 1.122 to the power of 30. Let's go to the calculator. 63,100 times 1.122 to the power of 30 gives me a bit of a long number. So this is 1994412.865. Right, we want this to the nearest 100,000. So that's the first three digits there, hundreds, and then up to a million there. So to the nearest 100,000, we're going to have to round this 900,000 there to the nearest thousand. That would go up to a million. Okay, so this is going to be 2 million, right? So 2 million to the nearest 100,000, £2 million to nearest 100,000. Perfect. So that's our answer there. Hopefully that all does make sense. If you do have any questions or queries though, do feel free to drop a comment below and I will get back to you.